Hey y'all, today we're going to talk about 3 Pythagorean identities. Make sure before you do today's video that you have done the previous day's work, otherwise it's going to be kind of confusing. So make sure that you've gone through and done your recap of SOHCAHTOA and make sure that you've taken a look at the 6 reciprocal functions from yesterday. So today we're going to take a look at 3 Pythagorean identities. There's also another video in Canvas that you should watch before this one. It'll show you how these identities were found, but these 3 identities are set in stone. They've been around for centuries and centuries. They are proven. In fact, it is what it is. So we're going to look at those 3 Pythagorean identities today. All right, Pythagorean identities. The first one is sine squared x plus cosine squared x is equal to 1. The second one is 1 plus tangent squared x is equal to secant squared x. And the third one is 1 plus cotangent squared x is equal to cosecant squared x. Now these x's, they can be written with a theta. So remember, theta is an angle. So it can be sine squared x or sine squared theta x, or it even can be some other Greek letter. So don't let the ending of it deter you or try to change your mind or anything. It could be an x or a theta. So these come from the unit circle and right triangle trigonometry. So we're going to use these 3 identities along with the 6 from yesterday to help us simplify some expressions. Before we do that, I just want to do a quick recap to show you that I can manipulate these equations. So even though the first one, the one in the black, is one of my trig identities, Pythagorean identities, I can manipulate it to also make the 2 that are down at the bottom. So suppose that we subtract sine squared x from both sides. And I do the same thing on this side. So if I rewrite that, then I have the second equation down here, the one that I'm putting a star by. So I have cosine squared x is equal to 1 minus sine squared x. Because these sine squared x's would cancel. These are not like terms over here. So I'd be left with cosine squared x is equal to 1 minus sine squared x. The same is true if I wanted to subtract cosine squared x from both sides. That would give me this third equation that's down here at the bottom. Sine squared x is equal to 1 minus cosine squared x. So even though I'm starting with the one that's in the black, I can manipulate it and still come up with a true statement. Very similar to, let's go way back here. Very similar to if I said 3 plus 5 is equal to 8. I can manipulate this and it would give me an equation that's also true if I said 3 is equal to 8 minus 5. Or what if I said 5 is equal to 8 minus 3? So these expressions are the same. So we are going to get into some problems now. So let me get rid of this, and then I'm going to disappear, and we're going to move on to actually do some problems. All right, here is the first one that we'll take a look at. So simplify 1 over cosine squared x times 1 minus sine squared x. 2 tips or things of advice for you to do. When you do these problems, make sure that you either try to make them all be the same trig function. So either all sines or all cosines or all tangents. Try to make sure those are all the same. And use your identity. So just because it says sine squared x plus cosine squared x equals 1, you may not see it written just like that. You may have to do a manipulation like I just talked about on the last slide. So off we go. So I'm going to keep the 1 over cosine x. I'm not going to do anything with that. I'm just going to bring it down. So in math, when you don't touch it, you just bring it on down. However, I do recognize that this 1 minus sine squared x, that corresponds to this first Pythagorean identity over here. So if I just subtract sine squared x from both sides, then I get cosine squared x. So I made a substitution. I took away the 1 minus sine squared x. I made a substitution with an equivalent expression that means the same thing. So that is cosine squared x. When you multiply fractions, it's top times top and bottom times bottom. So this now gives me cosine squared x over cosine of x. I have two cosines that are on the top, and I have one that's on the bottom. So one of those is going to cancel out. So it's kind of like over here, I got two on top and I got one on the bottom. So ignore this. This is just me kind of brainstorming to show you that I have two cosines on top and one on the bottom. So one is going to cancel, and we're just left with cosine x. Now that is our final answer. You know that it's your final answer when you cannot simplify anymore. You cannot break it down anymore. There's no other substitutions. I can't do Pythagorean identities. I can't do reciprocal identities. It is what it is. So that is my final answer. And notice for this particular problem, I used a Pythagorean identity and I also used a reciprocal identity, and that's fine. Nothing is wrong with that. All right, let's take a look at another problem. We want to simplify cosecant x times sine of x. So I'm going to make some substitutions. Again, try to get them all to be one trig function. Sine, cosine, and tangent are our parent functions. So you might want to try to stick to those in the problem. So change the other functions to be one of those. So the cosecant of x, I'm going to make a substitution. So if I come down here, where is this? This one right here that I'm circling in the pink. Cosine of theta is equal to 1 over sine theta. So I can make a substitution. Again, x and theta are interchangeable. They're just standing for some missing angle that I don't know. So I can make this problem be 1 over sine x. I can't do anything with this sine x, so I just bring it down. When you multiply fractions, you do numerator times numerator, denominator times denominator. So now this problem is sine x over sine x. And anytime in math you have the same thing on top of each other, it simplifies to the number 1. So my final answer is 1. So this is no different than 7 divided by 7 gives you 1. 8 divided by 8 gives you 1. 100 divided by 100 gives you 1. Anytime you have the same thing, it cancels out. You can get rid of it. So this particular problem, I started with a cosecant and a sine. I used one reciprocal identity to simplify it, and it gave me the number 1. All right, next problem. We're going to simplify 1 over tangent squared x plus 1. So we're going to simplify 1 over the tangent squared x plus 1. Now, I see this down here. And the more that you work with these identities, you will notice, hey, tangent squared x, that must be this one over here. That must be one of my Pythagorean identities. So how can I manipulate tangent squared x plus 1? Well, it's right here on the left side of my equation. I can make a substitution, and that's going to give me 1 over secant squared x. And sorry for the bad handwriting. It's hard to write up here, as you all know by now. So this gives me 1 over secant squared x. How did I know that? Because I used this Pythagorean identity, and I made a substitution. So this left-hand side that I'm boxing in over here, this left-hand side was equal to secant squared x. So I was able to make a substitution. Now, secant squared x is one of our reciprocal identities. And if I notice right here, I'm going to circle this one. 1 over secant theta equals cosine of theta. What we have in my problem is 1 over secant squared x. So this must reduce to cosine squared x. And that is our final answer.